Good morning, ladies and gentlemen. I am Mr. Eicher, again, with the bow tie and my favorite purple shirt. It was a gift a couple years ago. In this video, we're going to be deriving the law of sines. We saw in the previous video how to find an area of a triangle using a sine ratio, and we're going to use that area formula to derive the law of sines, just so you can see where it comes from. And then we'll do a practice problem or two using the law of sines to find missing angles and sides of a triangle. And the benefit of the law of sines is you don't need a right triangle. With our SOHCAHTOA ratios, you need a right angle in your triangle, whereas the law of sines that we're learning today is much more robust, and meaning you can use it in a lot of different cases because you don't need a right angle. So let's get started. Write the area of triangle ABC, here's triangle ABC over here, in terms of angle A. So in the previous video, we learned that we could write the area to be 1/2 the product of two sides, that would be B and C, times the sine of their included angle. So that would be BC times sine of the included angle A. We could also write the area in terms of angle C. So here's angle C. That would be the product of their included sides, A and B. So 1/2 A times B times the sine of their included angle, which is angle C. So we have two formulas, and both formulas equal the area of the triangle. Well, the area of the triangle is a set constant. It is the area, whatever this area is. It's going to be the area regardless of what angles and side measures we use to find that area. So what we can do is we can set these two equations equal to each other. 1/2 B times C sine A would equal the other area formula, since one area would equal the other area. 1/2 AB times sine of angle C. And then we can simplify this a little bit. We can multiply both sides by 2, that'll get rid of the 1/2. We can divide both sides by B, that'll get rid of that. And then just to make it a little more memorable, we'll divide both sides by C to get rid of this C, and we'll divide both sides by A to get rid of this A. And then what we have is sine of A over the side opposite of that angle, capital A, equals sine of angle C divided by the side opposite of that angle, capital C, which is lowercase c. So we get this relationship, and this relationship is called the law of sines. It's called a law because it's like a formula, it always works. And then it's called sines because it's using the sine ratio. So the law of sines, let triangle ABC be any triangle with sides A, B, and C representing the measure of the sides opposite of those angles, A, B, and C. Then we have a couple different ways that we could write it. We could say sine of A over lowercase a equals sine of B over lowercase b, and that would equal sine of C over lowercase c. Whenever we use this to solve, we only ever use two fractions to solve. Or we could use these two fractions, or we could use this equals this one. But it's true that all three are equal. We also could write it like this and write a reciprocal of each one. The side A divided by the sine of the angle opposite of A equals side B over the sine of the angle opposite of B equals side C divided by the sine of the angle opposite of C. So we could write the law of sines in either way. I typically write it this first way, but if you want to, you could write it like that too. So let's check out this law. It says solve the triangle. When you're asked to solve the triangle, you need to find all the angles and all the sides. With the law of sines, round the sides to the nearest thousandth and the angles to the nearest tenth. So in this triangle, we have triangle ABC, and we have two angles provided. Let's find this angle C, the measure of angle C, Let's find that one first. We don't need the law of sines to do that, but I notice that we have the other two angles, 45 and 50. The sum of the interior angles of a triangle is 180 degrees. So if we subtract the other two angles, we could find the measure of angle C. That would be 80 degrees. So let's put 80 degrees right in there so we know that we have it, we don't forget. It's a really important step now. When using the law of sines, I recommend finding the angle in the side pair, which is referring to this side 12. The angle opposite of that side is 55. We're going to base our law of sines ratio, this formula up here that we had, we're going to base that first on that given angle side pair. So let's write sine of 55 degrees divided by the side opposite of that, which I've highlighted as 12. So we're going to start there. After that, we need another fraction. It's going to be sine of some angle. And really you could pick either one. So since we're given 45 here, we'll use 45. And now I need the side opposite of 45. Well, that's side A that I'm looking for. So I'm going to put a little A right here. And then we solve this. In order to solve this, we're going to multiply A times this sine 55. We're going to multiply 12 times that sine of 45. We could do that because it's a proportion, one fraction equaling another fraction. So it would look like this. Multiply both sides by A, we get A times sine 55. Multiply both sides by 12, we get 12 sine 45. And then finally, for A, we would divide both sides by sine 55. So now A is going to be all by itself. So we have A equals 12 sine 45 degrees over sine 55 degrees. Now let's talk about how to type that in your calculator. Recommend taking your calculator out. We'd have 12 times sine 45 and then press enter. You get a long decimal number. It's 8.485281374 in your calculator, and then hit the divide button, and your calculator, most calculators at least, will use that entire long decimal and then just divide that whole thing by sine 55. So the answer you should get for the length A is 10.359, rounding to the nearest thousandth. 10.359, and it's a side length. We're not told what the units are, so that's just 10.359 units. So let's write that in here, 10.359, and that's side length A. I do want to point out, just so you can get a sense if your answers are right, 55 is opposite of 12. Since 45 is smaller, 45 degrees is smaller than 55 degrees, then the side length A should be smaller than 12. So this side, since 45 is the smaller angle, A is the smaller side. I know it doesn't look like that on the diagram. It's not drawn to scale. But 55 is going to have a side bigger than that. So likewise, 80 is the biggest angle. So that means this side is going to be the longest side. Again, it's not going to look like that on the diagram. It's not drawn to scale. But side C should be bigger than 12. So let's solve for that third thing. Again, we're going to start with our highlighted, the one that we had here highlighted in green. We have sine 55 degrees. We have to use the law of sines again. We cannot use the Pythagorean theorem. If you pause to think about that, we can't use the Pythagorean theorem because it's not a right triangle. So we have to use the law of sines again. We'd have sine 55 over 12. Now we're looking for this side C. So we're going to use the angle opposite of C, which is sine of 80 degrees over the side length C. If you'd pause the video, see if you could solve for C. Give you a second to do that. You should have something that looks like C times sine of 55 degrees equals 12 times sine of 80 degrees. So C would equal 12 sine of 80 degrees divided by sine of 55 degrees. And again, I'd encourage you to make sure you can type that correctly in your calculator. That would be 12 sine 80, hit enter. Keep that whole decimal in there and then divide sine 55. And we get angle C is roughly 14.42, and rounding to the nearest thousandth, this would make it a 7. So again, notice that the smallest angle is opposite the smallest side, the shortest side, and the largest angle is opposite the longest side, 14.427. So I'm going to, maybe I'll circle my answers in red so you can see them. We found this one, we found this one, and we found this one. Thank you for watching this video. In this video, we found missing sides with the law of sines. In the last video, we'll find missing angles with the law of sines, as well as do an application, a word problem. See you next time.